Hello and welcome back for lecture 7. This week we'll be talking about data. So in the previous lecture we had a couple guest lectures. If you remember, Brent and Eric from React Navigation. They talked through the library that they wrote. They talked through a few of the different navigators that they have. One was the switch navigator, which was very similar to a construct that we learned in the previous lecture before that, whereby you have one screen and then it will completely switch to another screen, and the first screen would be completely unmounted. They talked about the navigation prop, which is a prop that's passed down to every single navigator. On it are things such as params that you can pass into each navigator, or maybe the navigate method, which allows you to navigate to a different screen. They talked about stack navigator, which was the navigator that allowed you to navigate to new screens, and new screens would actually get pushed onto a stack, which gives you the ability to pop or go back. We also talked about configuring navigators, which was allowing you to maybe change the header color or put some buttons at the top. They talked about a tab navigator, which was the navigator where there's either a tab bar on the bottom or on the top, which allows you to swap between two screens. And then lastly, we talked about composing navigators, which was nesting navigators, so maybe having a stack navigator within a tab navigator, or the like. In this lecture, we'll be talking about data. Up until this point, all of the applications that we've been doing in class have been self-contained, where all of the data that we need for the app is either generated within the app or created during the time of the app. But not all apps are self-contained. Any app that wants to rely on information not computed within the app itself needs to get it from somewhere. And where can we get it from, or how do we go about getting that data? Well, we end up communicating with other resources using an API. And so how might we do that? This is similar to a problem that we face so far. Maybe you have two components that need to talk to each other. And how might we get those components to talk to each other? So if you imagine what an application looks like, it's a tree, right? A tree of elements, of React elements. So maybe you have your app, and maybe you have some thing over here that's maybe a form. And maybe we have an input and another input. So what happens if we want these two inputs to talk to each other? Or maybe one input is dictated by the value of the other input. And so we want to somehow have these communicate with each other. It's not very React-like to have them directly talk to each other. In React world, the way we generally do that is by passing props down to things. And so where might we be able to put that logic in order for these two childs to talk to each other? Well, we need to look up the tree, right? We need to maybe do that in a shared parent. And so in order to have these two inputs talk to each other, or at least have them influenced by the value of the other input, we need to put that logic in a shared parent of the two. And so all of that logic would go here, within their shared parent. And so we can kind of draw an analogy if we want two applications to talk to each other. So maybe I have an application on my phone, and David has an application on his phone. How are we going to get those to talk to each other? And so you can imagine this tree exists, but also some other tree exists. And so maybe we have my phone and David's phone. So how are these things going to talk to each other? So in the React way, the way we did that was we had these two components talk to each other via a shared parent. And the same thing could be true with these two phones. We need to have them talk to each other through some sort of shared parent. And maybe that shared parent is some server or something up in the cloud. And the way we talk to that is via an API. And so if we want these two phones to talk to each other, we need to have them talk through some shared parent. And the way that we'll talk to that parent is through this thing called an API. And so what exactly is an API? Well, it stands for an application programming interface. What the heck does that mean? Well, it's a defined set of ways with which a resource can be interacted. We've seen APIs thus far. So every single React component actually has an API. And how do you interact with these React components? Well, you pass them props. And what dictates the props that they want to see? Well, it's just the way that that component is implemented. What other sorts of things have we seen in class that have APIs? Well, a class does. If you remember, when we write classes, these classes have methods. And how do we interact with that class? Well, we invoke those methods. And so those methods are actually an API with which you can interact with those classes. And just like these things have APIs, so do web services. And so say there's some service up in the cloud, and the way you want to talk to it would be using its API. And so how are APIs created? Well, oftentimes providers, or in other words, the people who create those APIs, a lot of times they get to decide what the API looks like. But that's not always true. Can anybody think of an example where an API is decided for you? I'll give you a hint. We've been using it all class. JavaScript's actually an example of this. So the people who write JavaScript don't necessarily get to decide on what that API looks like. It's actually dictated for them by ECMA. So if you remember back to ECMAScript, and when we talked about things like ES6 and ES7, those are actually specifications for this language that JavaScript then implements. And so the JavaScript API is actually dictated for them by these ECMAScript proposals. And for us consumers, or the people who actually use those APIs, in order for us to know exactly what the APIs are, we actually need to look at the docs. And so we need to just read the docs in order to know how to use these APIs. And so let's actually look at an API that's running right now. And so this link here, randomuser.me, is an API that's free and runs up in the cloud. And so say we wanted to go use this API called randomuser.me. How do I know how to do it? Well, it turns out they have a pretty decent documentation page. And if you scroll down, you can see how to use. The way to use this random generator API is to use this thing called AJAX, which we talked about in CS50, asynchronous JavaScript and XML. So in other words, we can send fetches without refreshing the whole page. And so ignore this usage of that AJAX. We're going to use this thing called fetch in a little bit. But this will show you how to use this API. So say we want to get a bunch of random users. The way we do that is we visit this URL. So if we visit https://randomuser.me/API/?results equals 5,000, we will actually get 5,000 results back. And so let's just visit that URL. So if I just copy that, open a new tab, and paste that, I get a bunch of this stuff called JSON, or in other words, JavaScript object notation. And if you look closely, you see results. This first person's, their gender is female, their name is Miss Nicole Ramos, their location is at this address, they live in this city, and a bunch of other information about this particular user. And if we scroll down, we'll see 5,000 other randomly generated users. And so what else can we do? Well, we can actually specify a gender. If we only wanted females, we can do gender equals female. So if we, rather than doing results equals 5,000, did something like gender equals female, and if I spelled female correctly, then we'll see we get a bunch of people, and every single one is female. I wonder what else this API can do. Oh, we can dictate what these passwords look like. So every single user that comes back has a password, and we can actually decide what that password looks like by passing in some parameters to this API. What else can we do? We can do seeds. So if we want to get the same results back every time, we can pass in a seed, and we're guaranteed to get the same results. We can determine the format. So we can get JSON or CSV, YAML, XML. We'll stick with JSON. We can use previous versions of the API, which we don't really care about. And lastly, we can determine nationalities. And so if you look through here, you might see some people that don't have American formatted names, or maybe their date of births are not formatted in the same way, or maybe their phone numbers are formatted slightly differently. And I don't see one immediately scrolling. Oh, here we go. This is not English, and so it might mess up our app. And so we can dictate exactly what nationality we want by passing this in, nat equals GB, or in our case, US, So if we do nat equals US, then we're guaranteed to get back only people with nationalities from the United States. And so how do we actually go about making these network requests? Well, it turns out this thing called fetch is polyfilled for us in React Native. What does polyfilled mean? Well, it means that this method may not be natively part of JavaScript, but it's implemented to match the usage of the fetch method in the browser. And so fetch is a function that comes in all browsers, and it allows us to make network requests asynchronously, but it's not natively part of the JavaScript spec. And so what a polyfill is basically a re-implementation of that same specification. And so the people who maintain React Native actually re-implemented fetch for us and allows us, puts it in the global scope so that we're allowed to use it anywhere in our React Native. And so how do we use fetch? Well, it expects a URL and optionally some configuration. And so let's actually go and use it. So let me just open up a browser console, and I can do fetch and then give it a URL. And so let's just use this URL here. And do fetch that URL, enter, and I see this thing promise pending. What does that mean? So fetch returns a promise, which is fulfilled with a response object. And if you want to look at the documentation for fetch a response, you can do it at these links. But what is a promise and how to use promises? Well, this is something that we talked about in an earlier lecture. Promises allow us to write asynchronous and non-blocking code, and it allows us to chain callbacks and/or error handlers. And how you do that? Well, there's this thing called .then, which executes the callback that is passed in as its argument after the previous promise block returns. Analogously, if there's an error, then whatever we pass to .catch is executed with that error. And so let's actually go ahead and use that. And so if we want to do something like fetch and actually play with the response that comes back, we're going to have to put a .then following this. So we can do .then. We're going to get some sort of response. And let's just console log that response. Well, now it goes ahead and does this fetch, returns a promise, and we see it console log this response here. And if we inspect it, we see a bunch of stuff. We see body use false, headers, and in it are any headers, OK, true, redirected false, status 200, type basic, URL. What the heck is all of this stuff? Well, if we were just to look at the documentation for response, we can see exactly what comes back as a response object. I happen to know exactly what this response object looks like, and I can do something with that response called response.json. And what that does is it actually unwraps the JSON that comes down in that response. And what does it return? Well, it returns another promise. And so we can chain another .then here. With that, we can call it result, and go ahead and console log the result. And now we see this console logged. Results is an array 1 and some info. And if we look at the results, we can see this one person. So what if we wanted to maybe get more users back? Well, we're going to have to go check the documentation and see how we get more users. And so if you remember at the very top, we could actually pass in a number of results and get that number of results back. And so if we were, again, to do random user, and instead of doing nat US, or in addition, we can do results equals 50. I'll put an and there to chain these, and then send that, and we get back now an array of 50 people. And if we look at the results, we can see each person and inspect that object. And if you want to look at more usage of promises, you can visit the documentation at that link. And as we talked about in an earlier lecture, there's actually an alternative to promises now. So rather than doing .then.then.then.catch, which might be confusing if you're not used to thinking asynchronously, we can actually use this new thing called async and await. And what this allows us to do is to write asynchronous code as if it were synchronous. And it's important that I say as if it were synchronous, because that doesn't necessarily mean that it is in fact synchronous. This is still non-blocking. And so if we want to use this, then we can just mark a function as async, and it will return a promise. And within an async function, what we can do is we can await the value of another async function or promise. What does that look like? Well, rather than just doing this thing called fetch, let's write an async function called fetch users. And in that function, what are we going to do? Well, first, we're going to send off this promise. So we can do, send off this fetch, so we can do fetch this. And we're actually going to assign it to a variable. So let's call that results, or response. So we do have this const response equals fetch this thing. But since fetch is a promise, we can actually tell JavaScript to wait for the value of that promise. So we can put await. And what that will do is it will wait for that that promise to resolve, and then set this response variable to that result. And I put it in air quotes because it's not actually waiting and halting the program. It's just doing that behind the hood. It's still all asynchronous and non-blocking. Well, now that we have a response, now we have to get the JSON out of that response. And so just like above, we did this thing called response.json. We can do const JSON, or result, equals response.json. And again, since response.json returns a promise, we just have to wait for that promise to fulfill. And so if we put that await keyword in there, then now result is going to get assigned the response.json when that returns from its promise. And now what? Now we have the actual result. And so now if we want to do the same exact thing as we did here, we can just do console.log that result. And now if we go ahead and invoke fetch users, we see that the promise is returned, and we see all of the results printed out here. And so these two things are functionally the same, this long fetch.then.then, and this async function fetch users. And if you notice, this one looks a lot like code that we've written thus far. It looks very synchronous in nature, but behind the hoods, it's doing a bunch of asynchronous things. But what happens if an error occurs? So in promises, we do it with a .catch. But there's no .catch in this async thing. So in order to do that, we can actually use a try-catch block. So if we wanted to add error handling to this fetch users, what we would do is wrap this all in a try-catch block. So we could do try all of this, try all of this, and if that works, great, but otherwise, catch. Or in other words, if an error happens in these 3 lines, don't halt the program and don't immediately crash with an error. Actually allow me to do something with that error. And so what are we going to do down here? Well, we can do whatever we want. Maybe we're just going to console.error, this error, and call it a day. And so now if we call fetch users with error handling, even though there's no error, if there were an error, this would catch it. And so now let's actually go back to that contacts app that we've been writing over the past few weeks. Up until this point, the way that we're generating contacts is by invoking that function that generated random contacts. So if you remember from past weeks, we had this file called contacts.js, and within it, we hard-coded a bunch of names, and at the very bottom, we exported an array that just created a bunch of random contacts. But now, rather than doing that within the app itself, we're actually going to hit an API for all of that information. And so let's go ahead and use that API that we've been exploring thus far and generate those random users from their API rather than doing it within our app. And so in order to do that, we're going to have to do some data fetching. And so where might we want to do that? So currently, the place that we're doing all of this is in app.js. And so if you look at the top of app.js, you see us import contacts from contacts. And that goes ahead and grabs all of those random contacts that we created and imports them into this app. And at the bottom of the file, we see in our class app, we put the state, initialize the state to be whatever those contacts were. But now, rather than using those contacts, let's start with no contacts. And let's actually go ahead and fetch those contacts. And so these contacts, rather than being generated from within the app, are going to be fetched from that API. And so let's first do it with promises just to practice. And so where might we want to do this? So we want our application to go ahead and fetch all of these random contacts as soon as it starts. But we don't want to hold up the application as it's fetching. And so how might we hook into this application and get it to send the request when it starts? Does anybody remember what we could use to do that? Yeah. Yeah, we can use component did mount, one of the React lifecycle hooks. And so we can do component did mount. And within component did mount, we're going to want to send out that request. And what does that request look like? Well, it looks something like this. Not exactly like this, but it's a good starting spot. So we're going to fetch from this URL. Then we're going to extract the JSON out of that response. And then we're going to console log that result. But rather than console logging that result, what should we actually do with the result? And let's rename result to contacts. Actually, let's first remember exactly what this looks like. And so if we go ahead and execute that, we get back this object with the results key, where that results key has a bunch of random users. And so here we know that contacts is not actually the context that we want. It's a response object or results object. But what do we actually care about? We really care about only that results key. And so let's go ahead and do this .set state and set our contacts to be equal to that results dot this key called results. And since we only really care about one key in this object, we can go ahead and use that object destructuring. So we can say we only care about the results key of this object and assign a variable called results to that. And so now we have some shorthand to do exactly what we want. And so if we go ahead and save this, we can watch what happens. So when we log in, undefined is not an object. So what the heck is going on here? I thought that we were doing what we wanted. So let's actually first console log what we're getting. So before we go ahead and set state, let's console log those results. So when we log in, we see a bunch of things. It's working. Our request is sending. And what does this look like? Well, we see there's an object, there's a cell, there's a date of birth, an email, gender, ID, location, login. There's a bunch of stuff that we cared about, but we get this red screen called undefined is not an object. What could be happening here? Well, we have a small hint. Evaluating contact.name 0.2 uppercase. Where are we doing that? Well, we're assuming that the data that comes back is the same as the data that we had in our original application. But that's not necessarily true. So let's look at the row that we defined earlier. In this, we assumed that each person that came down had a key with a name and a key called phone. But that's not necessarily true with our new objects. The phone is still called phone, but name is actually now an object where we have first, last, and title. And so props.name might not necessarily exist. So let's actually push this problem to a little bit later and forge ahead with this data fetching that we're doing. So we know that the data fetching is working, and we're doing it in component did mount here. But right now we're using this promise, this .then notation. And we can actually modernize a little bit by using this async await. So how might we want to do that? Well, in order to get from promise to async await, all we need to do is await this and assign it to some variable. So if we did const response equals this, now response is going to wait for the fetch to come back and wait for that promise to fulfill, and then set itself as a variable. Then what did we want to do with that response? Well, we wanted to do const, we'll just call it results right now, equals that response.json. See how that's exactly the same as what we were doing before. But if you again remember, response.json actually returns a promise. And so what are we going to do with that? Well, we need to wait for that promise to fulfill. And so we can do await. Or in other words, just wait for that response.json promise to be done, and then assign that variable, the result, to this variable called results. So that does this. Lastly, what do we want to do? Well, we actually didn't care about that object, that entire object. We only cared about the key called results. And so we can go ahead and do this destructuring here. So we say whatever object comes back from response.json after the promise is fulfilled, we just get the key called results and assign this variable called results to that. And lastly, what did we do? Well, we wanted to await. We wanted to console.log that. So again, the same thing here. And then go ahead and set the state as so. So we're all good, right? This is good to go. Let's go right. Syntax error. Await is a reserved word. What is going wrong here? Well, if you remember, the only time you can use await is within an async function. And component did mount is not an async function. So how are we going to go about and fix that? Well, we can just create a new method called, well, one quick way is to do this. We can create an anonymous function here. So we can say, if you remember back to an early lecture when we talked about ifs, or immediately invoked function expressions, we can just create an anonymous function here. So we could have an async function that does this. And then immediately invoke it. So again, an immediately invoked function expression. And so we have an anonymous asynchronous function here that does all of these things. And then we wrap it in parentheses and immediately invoke it. And that will immediately invoke that asynchronous function. And so if we go ahead and save that, then everything, we need to use an asynchronous arrow function. Just because if we use a normal function here, this binding down here does not make sense in the eventual state of the app. And so by using an arrow function where we bind the this to be the this lexically here, like we want, and again, it all works, and we get that same error that we were seeing before. But this is a little bit messy and hard to read. And so what is a better way to structure this such that it's much more easy to maintain and read? Well, we can abstract all of this out into its own function. And so we can just delete all of this. Actually, let's just go back a few steps until we were here. So this is where we were, and this is what we want. But let's say rather than calling this component didMount, let's call this fetch users. So now we have a method called fetch users, and it's actually an asynchronous method. But we want to set it as an arrow function so that we're sure that the this binding works. And then now we just have to call fetch users. And so we're going to call that. Well, we can do that here. We can do component didMount, and then immediately call fetch users. And if we do that, fetch users doesn't exist because I meant to do this dot fetch users. If we go ahead and do that, then again, we get that same error because it worked. And so now let's go ahead and fix this error. And so if you want to go ahead and read up again about async and await, you can go ahead and follow those URLs. So let's talk about transforming data a little bit. So something got messed up. The shape of the data that was returned from the API wasn't ideal. It wasn't the data that we thought it should be, or that we originally wrote the app to be. And so where might we want to do this transformation? We can do it every single time we render a new row. So every single time we show a user's contact information, we can go ahead and say, oh, we know that the data that we got back from this API endpoint was not what we really wanted to. So let's go ahead and make sure that what we're actually showing is from the correct keys in the new API. But that doesn't seem very good, right? Every single time we re-render, we're going to have to redo that transformation. And so where might be a better way to do that? What if we did it right when that data came back? That's good in a few ways. One, it's more efficient. We only have to do it once. So as soon as the data comes back, we go ahead and transform the data to make it look like what we want it to look like, and then we're done. Every single time the app re-renders, we already have the data that we want. But it also gives us this thing called an abstraction barrier. So we've talked about abstractions a little bit, and how by creating an abstraction, what we're doing is we're taking some aspect of a problem and breaking it off into its own small problem. But what is an abstraction barrier? It means you don't really care what this abstraction is. You only care what is outputted at the very end. And so by transforming the data outside of the component that cares about it, that component really never cares about how we got that data, or where we got that data, or how it was transformed. It only cares about what the data looks like when it receives that data. And so if we go ahead and do all this transformation as soon as we get that data, then the rest of our application doesn't really care what the API looks like. The API might change, and maybe we'll change the way that we transform the data in response to that. But the rest of our API, the rest of our application doesn't care. There's an abstraction barrier between our application and that API. And so how might we do that? Well, right now, fetch users is something that we created within our app.js. But our app.js doesn't really care where we're getting all these users from. So if this was randomuser.me, or if this were randomuser.com, or randomusers.org, or anything like that, our application really doesn't care. It only cares that we're getting those users from somewhere. And so we might want to take all of this logic and move it somewhere else. And where might we want to move it? Well, let's go ahead and create this new file called api.js and open it up. And so now we've gone ahead and created a separate file, just like the rest of our application. When we have a component that isn't necessarily needs to be defined within a particular other component, we can go ahead and create a new file for that component and abstract it out. We can also do that with our API logic. So our app.js doesn't really care where or how we're getting all of these users. It only cares that it's getting it. And so maybe we can take that logic and move it into this file called api.js. And so let's take this fetch users, take it out of app.js, and instead put it in our API folder, or API file. So we have this thing called fetch users. Let's export it. So we're exporting this const called fetch users, and what it is it's an async function that will await this fetch. It will take the results, console log the results, and then do this.setState results. That no longer really makes sense in what we're doing. This.setState, it really only makes sense in the context of a stateful component. And so what should we do instead? Maybe we should just return results. And so now what this function called fetchUsers is doing is going ahead and doing that request, is getting the JSON back, and then it's returning it. And so now, in our app.js, we can get rid of that. We can do import fetch users from this file called api.js. And now where are we going to use this fetch users function? Well, in component did mount. So now it's no longer this.fetchUsers. Now what we want to do is fetch users. And since this returns results, we could either do .then use these results and set the state with it, or we can again use that async await keyword. So if we want to use async await, we have to define another method here. So we'll go ahead and do async fetch users is a function that awaits fetch users probably not ideal to use the same variable name here, so let's just call this get users, and then this.setState those results. Oops, so if we wanted this to work, we should have done this. So again, this line and these two lines are functionally the same. But if we do want to stick with that async await, we can just create this new function, an async function called getUsers. Oops. Should actually be getUsers is an async function here. We can define a class property called getUsers, which is an async function which awaits fetch users, which we defined in a separate file within our api.js, grabs those results, and then just sets the state so that the contacts are those results. And then in component did mount, we could just invoke that get users. So we're back basically to the point that we were a minute ago. We still have that same error because the API, the shape of the data from the API, is not the shape of the data that we originally wrote our app for, which has been a problem thus far, but the data fetching is still working. And additionally, our app.js function, or app.js file, looks a lot better. So here, nothing within the app should really care about where we're getting that data. Nothing in this class file, I should say. All it cares about is that we're getting the data. And so by abstracting out this fetch users into api.js, we have now a nice abstraction, where if we wanted to change the API that we're getting it from, this class should not really care about it. Really, the only thing that should care about it is that API file. And we've gone ahead and moved all of that logic there. And so now let's try to get that, the shape of the data to match the shape that we're looking for. And so what is the shape that we're looking for? So if we look back into contacts.js from a few weeks ago, remember that a person has a name and a phone number, and that's it. There's no such thing as a first name and a last name. There's no date of birth, no nationality. We only care about the fact that they have a name and some phone number. And so let's go ahead and get the data from the API to look like the data from that our application is expecting. So first, let's go into our API file. So we have this here. What exactly does a user look like? Well, it's an object with a cell, short for cell phone, date of birth, email, all of these keys. And what are the only two that we care about? We care about name, which here is an object, and we care about phone, which already exists. And so let's write a basic transformation function, so a function that takes data and transforms it to look like new data, that takes an old contact, or a contact that's returned from this API, and makes it look like a contact that we're expecting. So let's create this function called process user, or contact, which takes a contact and returns a new object. And what does this object look like? Well, it should have a name, and it should have a phone, both strings. And what did a name and phone look like in the object from the API? Well, phone is just what we expect it to look like already. And so we can say the phone is just the contact.phone. But the name looks a lot different. So in our application thus far, a name was just a continuous string where it was their first name, a space, and their last name. But in this API, a name is actually an object with a key called first, a key called last, and a key called title. So how are we going to get this to look like what we want it to? Well, we can use those template literals. So if you remember, we can do backticks, which allows us to create a string literal, and within it, evaluate JavaScript expressions. And so maybe we wanted to have something called like a first name, a space, and then some value called last name, and call that a full name. Unfortunately, first name and last name don't exist, but we can actually get them. We can do that contact dot name dot first. And that will get us their first name. And the same thing is true with their last name. And so if we wanted to transform that name object into what we're looking for, we can just do contact dot name dot first. And then here we can do contact dot name dot last. And now we have what should, in theory, be a name. We have their first name separated with a space, and then their last name. And since we're wrapping it in backticks, these JavaScript expressions that are surrounded by this dollar and curly brace are just evaluated and then cast into a string. And then what do we do for phone? Well, we just grab the contact.phone because that was already matching exactly what we were looking for. And so now we created this function called processContact that takes a contact and turns it into what we're looking for. But how do we apply that to this fetch users? Right now we have the results. And how might we say, go through that results array, and for every single value in that array, transform it? We've talked about a function that does a very similar thing. It goes through an array, and for every single value, it passes that value into a function and creates a new array where every single value is the output of that function. So rather than just returning the results, what we can do is we can map over those results. And what do we want to do for each of those results? We want to take that contact and then pass it into processContact. Or in other words, we just want to process the contact. What does that mean? Well, we can do a dot map. So for every single value in this results array, we're going to invoke this function on that value. And what does this function do? Well, it's expecting a contact, and then it just outputs the contact that we're expecting. And so does that fix our problem? Yes, it does. So now we see a bunch of things. We see first name space last name, and we see their phone numbers. So do you see why doing this transformation right now is much better than doing it within the application itself? Since we already wrote the application, we don't know exactly where we use name every single time. It might be in the row, and it might be also done 10 other times in the app. And if we wanted to, say, move what used to be name as a string into name as an object with a first and last key, we're going to have to go back and change that every single time in our code. But by doing this here, we just have to do it once, and now it creates a subtraction barrier. So now our application doesn't really care how randomuser.me wants it to express a contact. And maybe they're gonna change that down the line. And all we need to do is update this transformation such that we take the contact from however they wanted to express it and just transformed it to look like exactly what we were expecting. And this is much more efficient because we just do it once. We do it as soon as we get all of the users, rather than having to do it every single time the application is re-rendered, every single time that we use this .name. So let's go ahead and take a break there, and then after this break, we'll forge ahead to finish implementing our contacts app. Hello and welcome back. So before the break, we were writing our contacts app, and we got up to this point where we have a bunch of contacts that we're fetching from an API off running in the cloud somewhere, and we're displaying those as users in our application here. And so this contacts list is actually a bunch of people who don't live in our app. They're actually hosted on some cloud, which we're getting all of these users using the API, the public API running in the internet. But we have one aspect of our application that's a little bit insecure. We have this page that says you're currently logged out, and when we click the press to log in button, we're immediately logged in. This isn't the most secure application ever, if the way that you log in is just to click. And so let's actually go ahead and implement a login screen using a real API. So if you look on the website at the code that is linked for this lecture, you'll see that there's this thing called this auth server. And in this auth server, it's a very, very simple server that I wrote. And if you look at the README, it's a mock authentication server. You can ignore post for now, to any endpoint, and it will act as a login. There's only a single username, a single user. Their username is username. Their password is password. And there's no way to add new users. But we can go ahead and use this server as an API. And so if you look at the installation instructions, the way to run it is by doing npm install. And then after the installation is done, we can go ahead and run npm start. And now we have an error because something is running somewhere. Here. So if we go ahead and run npm start, it goes ahead, starts the server, and now it's running. It's listening at HTTP localhost 8000. And if you go ahead and visit it, we can see that it's running. Currently returning not found, and we'll see why in a second. Let's go ahead and add some authentication to our application. So what is authentication? Well, it's a process to determine if a user is who they actually say they are. Because unlike in the real world, when I'm talking to somebody and I can immediately see who they are, the internet doesn't really work the same way. If you're an API and you're just getting a request out of nowhere, how can you really confirm that the request came from who they said it was? The way that we usually do this is by using a name and a password. Presumably, only the person with the name knows the password that they set. But how do we actually send requests with a name and a password? So the way that we configure requests in this random user generator is by adding it to the URL. And so if we wanted, say, 5,000 results, we just visited this URL here called https:// their API !results 5,000. But for authentication, that seems a little bit weird. Would we really want to do something like https:// some URL username equals Jordan, password equals my password? That doesn't sound very smart, right? Imagine somebody was using my computer after me, they want to visit that URL, and all of a sudden my browser auto-completed the whole thing that said, oh, user equals Jordan, password equals my password. Now all of a sudden I'm compromised and everybody knows my password. So this probably isn't the greatest way to transmit secure information. What might be a better way to do it? Well, it turns out there are these things called HTTP methods, and one that we commonly use is GET. This is the default for browsers. This is the default for fetch as well. So if I just go to randomuser.me/documentation and load the page, that sends a GET request to this. And I can confirm that by looking at my network traffic. If I refresh the page, I see a bunch of things happen. And if I inspect this request, I can see that the request method is GET. And what is the URL that I'm sending it to? Well, it's this request URL that I have typed in my address bar. So if I just go to this URL and hit enter, browsers will use a default request method of GET. And the same thing is true with fetch. If I just go ahead and type fetch this URL, it goes ahead and sends a GET request. And how do we add parameters to the GET request? Well, we do that by appending a question mark and chaining key value pairs by doing key equals value. And we separate them by this ampersand. And so if you remember earlier when we were talking about this API, we see question mark here, which means here comes some additional parameters. And we see key value pairs separated by an equal. And so the key here is results. And how many do we want? Well, we want 5,000. And down here, we could also have a separate parameter called gender or female. And what if we wanted both? I waved my hand at it a little bit earlier, but what I did was I said results equals 5,000 ampersand another key value pair. And if I wanted to chain a bunch more, I could do results equals 5,000 ampersand gender equals female ampersand nationality or nat equals US. And so just to demonstrate real quick, I can do nat equals US and results. Is it called results? Yes, it's called results equals 10. And also, I only want gender equals female as well. And if I go ahead and send that request, I get back what looks like 10 results. And every single person should be female. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so I can pass additional parameters by just doing key equals value after a question mark and sending the ands. And how do I know which key value pairs exist? Well, since I'm a consumer of the API, I'm at the will of whoever wrote the documentation. And so to know exactly what key value pairs are available, I just have to read the documentation for that particular API. But that, again, doesn't solve our problem. If I wanted to authenticate through some server, I don't want to be sending user equals Jordan and password equals password. So what might we do instead? Well, it turns out there are other HTTP methods, and one is called post. What is posting? Well, it's like submitting data or like a form or something to an endpoint. And the origin of this word post is actually from posting things to a billboard. And so if you wanted to add something, so add some new data to a billboard, you just post it up to the billboard. And so that's how this HTTP method or this verb came around. And so by posting to an endpoint, we can actually submit data. And where do the parameters go if not in the URL? Well, turns out there's actually a request body in this thing called a post. And so GET requests don't have a body, and so the only way to add parameters is through the URL. But in a post, you can actually put it into the request itself so that it's not visible in the URL. Which is good, right? If I wanted to now send a request to an authentication endpoint, I don't have to put my parameters in the URL. I can now put them inside the request body, where people who then go visit the page after me don't see it autocorrecting in my browser. how do I do that? Well, I'm probably going to use this thing called JavaScript Object Notation, or JSON. And so what I do is I post some JSON, and I add this header called content type application JSON. And I'll wave my hand a bit at headers, but basically what this is saying is, hey, API, the stuff that's coming in this request is JSON, or JavaScript Object Notation. And so my body has to then be a JSON string. And so now let's actually go ahead and start using this. So let's take a look at our server. Well, first let's run it. So it's currently running at localhost 8000. And if you remember, how do I actually use this authentication server? Well, I can post to any endpoint, and it will act as a login. And so now we know what post means. Posting is opposite of get. So rather than just visiting localhost 8000 in my browser, which is what I did, that does what? It sends a GET request. And so that's why it's saying not found, because it doesn't know what to do with that GET request. It only knows what to do with posts. And so now we can actually post to this and try to log in. And so how the heck are we going to send a post? Well, it's the same way that we sent our GET requests. So let's head over back to this console. And let's send a post request to our API. So let's do fetch http://localhost 8000. And let's just do that and see what happens. Well, we get not found. We try to get it. We see this thing called 404. We don't know what that means yet, but not found. Why is that not found? Well, it's because we know that we want to post to that endpoint. Actually, I have a feeling this demo is going to fail. All right, we're gonna forge ahead anyway, and this is probably gonna fail. But let's go ahead and send a fetch request to that same API, and let's add some additional configuration. And so if we wanted to send a post request, what we need to do is pass some additional configuration that says what method do we want to use. Well, we're going to use a method called post, and we'll go ahead and send it. And we can go ahead and look in our network. We can see that we sent this request. What is the URL? Well, it's localhost 8000. And what is the method? It's post. As opposed to the one that we had sent a few seconds earlier, which is a get. And if you look at the status code, it's saying 404 not found and 400 bad request. We don't really know what that means. But let's forge ahead and go ahead and try to implement this login screen. So what does the login screen look like right now? Well, it just says you're currently logged out, and we press this button, and all of a sudden we're logged in. Again, not very secure, and so let's go ahead and use our authentication server to make sure the user is who they say they are before letting them in. So where is this logic? Where does this logic live? Well, if we want to find it, we can open up app.js. Scroll down, we'll see that we have an app navigator. And what is the app navigator? Well, it's a switch navigator. If you remember back to last lecture, that is the navigator where it's either showing one screen or the other. And when you switch in between, they're actually unmounted. And so there are two screens on the switch navigator. There's the login screen and the main screen. And so we want to actually be working in the login screen. And so let's go ahead and find where that login screen is implemented. So if I just search for the login screen, I see it's used there and actually imported in from this URL /screen/login screen. And so now I know that if I want to affect that page, I need to go edit that file. And so let's cd into screens and look at that login screen. And here we have a page. We see export default this class, It's called login screen. It extends React.component. It has a class property, which is a function called login. And what does it do? Well, it just navigates to the main screen. Again, not very secure. And then we see that it's rendering some things. It's rendering a text element that says you're currently logged out, which is exactly what we saw. And we saw this button that says press to log in. And on press, it just invokes this function called login. And if you've never seen this before, there's a convention that says for methods that are only used within a particular class, use an underscore before that method. The community is a little bit torn on whether to do that or not. It looks like Eric and Brent like using that underscore login. But again, about half the community also prefers not to use that login, the underscore, because in other languages, it might mean this is a private method. But since private methods don't exist in JavaScript, we don't want to confuse people to think that it's a private method. So the community is a little bit torn. Brent and Eric like to use it. I will not use it, but I'll leave it as is, just in their honor, I guess. Let's actually make this more secure. So we don't want to just by default log anybody in. And so first, we actually want to go ahead and add a couple of text inputs that controls the username and password that we're going to send. And so let's get rid of this text that says you're currently logged out, and instead put some text inputs in. So we want one text input that is going to be used for the username. We want one for the password. What are we going to do when somebody starts typing their username? Well, we should probably update the value. And what is that value? Let's have it be this.state.username. And how do we change that? Well, on change text, we're going to call this.handle username update, which doesn't exist yet. So first, let's declare the state, where it starts with a username of empty string and a password of empty string. And then let's also declare onChange text, or handle username update, which takes a username and will update the state when it changes. So let's do this.setState, that username. And if you don't remember what this shorthand is, it's basically this. But rather than using the key and the value as the same string, we can actually use the ES6 shorthand like that. And let's create the same thing for password. And go ahead and make sure that this text input is showing what it should. And so the value here should be that password. And the onChange text should be the way that we handle that password. Cool. So now we have this login screen. And so you see it's expecting a username and a password, and we can type in the username here. And we can type in the password here. And if we press to log in, we're automatically logged in. If we type no username and no password, we're also logged in, which seems kind of weird. Why is that happening? Well, if you remember what happens when we press that button, we call this login function. And that login function disregards anything that we've typed and just navigates us to that main panel. So let's actually use those things. And so let's remember how we use that API for our login server. So let's just cut and paste that here. So we're going to have to fetch from this API. And if you remember from that README, it's expecting a post to any endpoint, so I can put / whatever, it doesn't matter. We're going to use method post, and we need to include somehow the username and password that we want. How are we going to do that? Well, if you remember back to the slides, if we want to post some JSON, which we do, we're going to have content type application JSON in the header. And we must include a body that is a JSON string. So let's do that. So we have method post. We also want to include some headers. The only one we care about is this thing called content type, and it should be application/JSON. And again, that's just telling the server, hey, here comes some JSONs. And where's the JSON going to be? Well, it's going to be in the body. I only know these configuration keys because I read the documentation on fetch. And so in order to put something in the request body, we have an object here. What do we want in the object? We want the username, and we want the password. What are the values for the username? Well, the username is going to be this.state.username, and the password is going to be this.state.password. But this isn't a JSON string. This is just a JavaScript object. And so if we want to make this a JSON string, there's this handy function called json.stringify, which takes a JavaScript object and turns it into a JSON string. So let's go ahead and send that fetch. And then I'm just going to use a promise here because it's faster for me to type. All right, so I'm going to take the result from that and console log it. So if I press to log in, it's going to log me in, but presumably it's going to console log something, and it's way down there. So let me just clear all these logs, start over. So I'm going to press to log in, and I see this response. And what is in the response? A bunch of things. And we see this thing called OK false and status 400, status text undefined, type default. Did it work? It's kind of hard to tell. All we're getting back is this thing, a number. And what the heck does that number mean? Well, it turns out that's not an arbitrary number. That number is actually part of a standard. It's an HTTP request code. So every single network response actually has a code associated with it. And these codes, they mean something. It tells you exactly whether or not this response or this request was successful. And so if everything went great, we get a 200. So 200 just means, OK, it worked. Good job. But not everything's a 200. If we see here that this particular one that we sent back got a status of 400. What is a 400? Well, that means a bad request. Or in other words, the request that you sent is missing some things that we wanted, or maybe it wasn't the shape that we wanted it to be. And it turns out there are other numbers that this could be. You could also get a 403, forbidden, which means you're not allowed to access this endpoint, or you did not have the correct permissions or the correct authentication in order to access this endpoint. There's also a 404, not found, which is this endpoint does not actually exist. So if you are browsing the internet, odds are you've hit a 404 page before. GitHub has a pretty nice one. So if you go to github.com/some gibberish string, you get back this not found page. And oftentimes, it's styled so that it's saying, maybe not everybody knows what a 404 is. And so we'll tell them, this is not the web page that you're looking for. This page doesn't actually exist. And so a lot of websites will choose to have some friendlier 404 pages, unlike our localhost 8000, which also just returns that not found. And if we actually inspect the network and visit localhost 8000, we can see that we got a status code of 404 not found. What other HTTP response codes are there? Well, one that you might see is 500, internal server error, which means the error was actually not on your part. There was an error on the server side code, and I'm just letting you know that this didn't work. I errored out, but I'm not going to keep you waiting. Of course, there's a bunch of other ones. There's like 401, 402, 418. I'm a teapot. This was actually a joke created by the people who made the HTTP response codes list. It was an April Fool's joke. This response code is only returned if you send a request to make coffee to a teapot. The teapot should return 418. I'm not a coffee maker, I'm a teapot. And if you want to look at all of the response codes, you can go look at the documentation at this link. And so now we know what this 400 actually meant. When we sent some stuff to the login, we got back 400 because this was not what we wanted. This was, there was no username or password that we included in that fetch. And so if we refresh and actually type the username and a password, press login, the status changed. It's no longer a 400. It's actually a 403. And what does a 403 mean? Well, 403 is forbidden, or in other words, those were not the correct credentials. So let's actually, since we have a little bit of extra time before diving into the React Native code, let's look at what that server-side code actually looks like. So if you're actually interested in what this auth server code looks like, it's actually also written in JavaScript. If you remember back from an earlier lecture, we talked about this thing called Node.js, which allows JavaScript to run on a server, even though it's a language that was originally intended to run only in the browsers. And so if we want to look at this, we can see what is actually backend code. And so I'll wave my hand at a lot of this express stuff in app.useBodyParser.json, which is kind of self-explanatory. It just means if there's JSON in the body, go ahead and parse it. But we see this thing called app.post. If you remember post, that means for any request coming in at this particular endpoint, and what endpoint do we care about? Star, which means every single endpoint. So if you post to any endpoint, we're gonna run this function that takes a request and a response. And what does it do? Well, it extracts the username and password. So familiar syntax, which we discussed earlier, which means look at this rec.body. And so if you remember, our fetch request had this key called body. And so now, since we embedded stuff into the body, now the backend server is actually looking at the body that we requested. So again, the front end and backend code are communicating with each other by using these familiar constructs. So rec.body is an object. It's the JavaScript object that we wrote on the front end. And it had two keys, if you remember them. It had a username and a password. If you remember this shorthand, it means create a couple variables called username and password and assign them to the username and password, respectively, keys from rec.body. And so we're taking those username and password. If neither one exists, return a result status code of 400 and send a string along with it called missing username or password. Otherwise, if there's no users in our username, say, oh, 403, this user doesn't exist. And if the username's password doesn't match the password, return 403, oh, this is an incorrect password. And if you're curious how we're storing these username password combos, we're just using an object. So we have declared at the top constant users, where the user called username, their password is password. And so in this particular way of implementation, we have users where the username are the keys and the passwords are the values. And so the only user we have in our system is a user with a username called username, and with the password of password. And so we're just going to continuously check against that. And so again, super simple. If they post to any endpoint, grab their username password. If they don't include a username or password, that's a bad request. That's a request that doesn't have the things that we're looking for. And so go ahead and tell them, oh, this is a status code of 400, send this string. And it's up to whoever wrote the backend to know all of the status codes and use the appropriate one. That's not guaranteed, but generally people are using the correct ones. Then we go ahead and see if that user exists by checking in that user's object. Again, this is not, in practice, this might be revealing too much information. If you imagine somebody can make a request that says, oh, does the user A exist? Oh, no, I got 403, it doesn't exist. Does the user called B exist? How about C, D, E, F? And they can go ahead and brute force every single possible string and figure out all of our users. So if this were your actual implementation, attacker could actually probe the user and find all of your usernames. But in practice, a server may have protections like block an IP if they send too many requests and stuff like that. But then if that user does exist, but the key in that user's object, which we are storing their password, is not equal password, which is what they submitted, then say, oh, this was the incorrect password. Again, with that 403 forbidden code. Otherwise, they are who they say they were. Let's go ahead and log them in, send 200. And if you remember what 200 means, just, OK, it worked. And then down here, you can see catch 404. So if it's not a post to anything, return a 404. Or create an error that's called not found, set the status to 404, and then go ahead and down here, send that status. And I'll wave my hand at the rest, but basically this web server takes a username and password if you post to an endpoint, checks to see if it works. If it's good, it returns 200. Otherwise, it returns the appropriate status code. So there's a peek at some backend code to see exactly how our server works. And so as expected, if you just visit localhost 8000 at a browser, if you remember, if we just visit some URL to browser, what type of request is it sending? It's sending a GET request, and so it is returning that 404 not found. And if we post with a username and a body, we get a 403 because it was the incorrect password. And finally, if we post with no username and no password, we're going to get that 400. So let's actually implement that page. So currently, our login is just sending a fetch request where the body is this.state.username and password is this.state.password, and then ignoring whatever comes back, and we're just navigating to main. So let's actually write something that makes sense. So rather than making this a synchronous login, let's actually make it async. And now let's do the result, or the response from this call is what happens after you wait for the fetch to come back. So now we have this. So we have, we're fetching to this URL. We're sending a post. We're telling the server, hey, by the way, some JSON's coming. Here it is. It's an object with a username where the username is this.state.username and password is this.state.password. Here you go. And now we can go ahead and say if response.status equals 400, because if you see we have your response.status, if it's 400, or if it's 401, or if it's 402, or if it's 403. And I need to count every single possible bad status code in order to know that indeed this is a good status. This seems really annoying. You can also use some greater than or equal to 400 and whatever. But it turns out there's actually something implemented for you. If you look at this object, you see this thing called OK, false. And if you look at the documentation for the response object, it actually does that for you. It does this if it's 400 or 401 or 402 or 403 or anything up to 500. It makes that check for you. And it basically exposes it to you as this key called OK. And so rather than checking for 1, for 2, and all of these, we can just check response.OK. Then they're good. Or in other words, if the response is equal to 200, because we actually know in the backend for this particular example, it'll only return 200. But we can go ahead and use this more general one. Then we're going to want to log them in. And we can go ahead and return, because that was successful. Otherwise, there's a problem. They did not do what they wanted to do, or their password was not correct, or they were not actually a user. So we're going to have to look at the text that came back. Because if you remember from the back end, we're actually getting some text back. It's saying, hey, this is a bad password, or hey, this user does not exist. And so just like we did this thing called response.json, which extracts the JSON from the request, there's also this thing called response.text. And so since we know that we're not receiving back an object, we're only receiving back text, we can await this. And again, that returns a promise. And so now, if the response was not OK, we know that there's an error. And what was the error? Well, we can just see what the backend is returning in that text. And so by doing response.text, that returns a promise with the text, and we can await that to get our error message. Then what should we do? Well, maybe let's do this .setState, and some error message is that. So now we have a pretty good thing going. We have this login is now an asynchronous function, or an async function. What is the first thing to do? Well, we send this fetch request to localhost 8000. We know that we're supposed to be posting some JSON because that's what the documentation said, and we're waiting for it to come back. When it comes back, we set the response to be this response variable. If it was OK, if we got a 200 back, then we're all good. We can go ahead and log them in. And the way we log them in this case is just navigating to the main screen. Otherwise, something went wrong. And let's figure out what went wrong. So let's extract from the response the text that came back. And so if you look at the documentation for the response object, you see that text is a method on there, and it returns a promise. And so we can await the response of that and extract the error message from that response. Then what do we do? Well, maybe we should tell the user that something went wrong. And so let's go ahead and put that in the state. So now we have an error called error message. And what are we going to do with that? Well, let's show it to the user. And maybe let's show it to them in some red text. So now, hopefully, we've just written some code that will send a request to log in with whatever username and password the user's typed. If it's good, we'll log them in. And if it's not, we're going to put an error message in the state. The error message corresponds with whatever response we get back. And then go ahead and show it to the user in render. So let's see if that works. Oop, can't find variable text because I didn't import it. And now if we press to log in, oh, missing username or password. It's not red. Styles.error. Oh. Now it should be red. And there we go. It's missing a username or password, which is good, right? Because we didn't type in a username or a password. Let's see if this works. If we type in a username, well, we're still missing a username or password, which is true. We're missing the password. And now that user doesn't exist. Because what does exist? Well, a user called username. And it's not a capital username. It's a lowercase username. Now if we press to log in, oh, we're getting incorrect password, which is good. Now it's actually showing some input to the user. But it might be annoying for users who have all lowercase usernames to have to manually go back and do a lowercase u. And it might also be bad for passwords to be shown. But let's just verify that this works. If we press to log in, lo and behold, we're logged in because we submitted the correct password. And so, yay, our auth is working. But it might not be the greatest user experience because we know that our only user is all lowercase, but by default, the keyboard is always capitalized. And so if the user wants to type in their username, they're always going to have to make sure to uncapitalize that first. There should be a way to do that, though, right? You'd think that with a text input, the people who wrote React Native should know, like, oh, maybe not everybody wants to capitalize all of the words. So how are we going to see if that does exist? Well, let's actually look at the API documentation and just look at the API for the React Native text input. So if we open up the documentation for text input, we can see all of the props that we can pass to this component. Or in other words, we can see the API for this component. And maybe one of them will allow us to not automatically capitalize everything. So if I command F for capitalize, oh, looks like there's this thing called auto-capitalize. And this tells the text input to automatically capitalize certain characters. And we can either pass in none, sentences, words, or characters. And the default is sentences. So the first letter of each sentence is by default capitalized. But we don't want that. So let's actually use this prop called auto-capitalize and pass in none to get what we're looking for. So here we have a text input, and we can say auto-capitalize equals none. So now, look, it's not automatically capitalizing. And so a user now can just type in their username without having to worry about this auto-capitalization. We still have a bit of a problem. We don't want the password to just be shown in plain text. And so maybe there's a way to do that as well. So again, let's look at the API. A lot of stuff here, so let me just do a command F. Maybe there's something to do with a password. So we see secure text entry. If true, the text input obscures the text entered so that sensitive text like password stays secure. The default value is false. Does not work with multi-line true. We're not using multi-line true, and so we might be able to use the secure text entry to hide the password. Let's see if there's anything else, because there are 3 hits. Keyboard type. It turns out Android can use this thing called visible password. That's not exactly what we want. And so we can actually use the secure text entry prop. So let's actually pass it in. So secure entry equals true. And it turns out there's shorthand for this as well. If you ever have a Boolean prop and you're passing in true, you can just leave that all out, and this defaults to secure entry true. Let's try that. And all of a sudden, we have username, and we have password. Oh, not working. Secure entry, secure text entry is what we're looking for. So now if we start typing in a password, oh, it does what we're looking for. And same with username. All of a sudden, we have authentication. Great, so now our contacts app is pretty much done. We have an API that goes ahead and fetches all of these contacts. We have authentication that allows us to only log in if we're the user that we say we are. And if we're not, then it'll tell us exactly that we're not. And that's all of the features that we're looking for. Unfortunately, our we have some stuff hard-coded in our login screen that doesn't need to be. Do you remember how in our application, when we had a fetch to some URL, the login screen doesn't really care what URL we're looking for. It only really cares that we're trying to log in. So maybe we should do what we did in the application class and abstract this out. So again, all of this logic doesn't need to be in this particular screen. So maybe we should abstract it out into that api.js file that we had created earlier. So let's go ahead and do that. So just like we're exporting a const called fetch user, let's export a const called login. It's going to be an async function that takes 2 arguments. It's going to take a username and a password. And what's it going to do? Well, it's going to do all of this. So I just cut and paste everything from the other file. And we have basically where we were when we were writing that fetch users function. We have a bunch of logic, and some of the logic was a little bit specific to the class, namely this.setState and this.props.navigation.navigate. Those 2 things don't really make sense in the context of this particular file, and so let's go ahead and handle those slightly differently. But this part is mostly correct. So we have username and password. What we're going to do is we're going to send a fetch request to localhost 8000, whose method is post. Their headers are set correctly. Now, rather than using this.state.username, we only need username and password. And if you remember, there's shortcut or shorthand. If we have keys and values that match in an object, we can use this shorthand. And so now we have the first 5 lines. We have the response should be awaiting this fetch request that sends a post to that URL. Headers are telling the server that JSON is incoming, and the body is just the stringified JSON form of this object that we create with a key of username, with the value username there, and a key called password whose value is the password that we pass in here. So what are we going to do with this this function? Well, if it's not OK, if it's OK, rather than doing this, let's actually just return true. Like, it worked. Yay. If not, let's actually throw an error. So rather than setting the state here, let's actually throw or create an error. So let's actually cool. So if it wasn't OK, we know that we're going to extract the text and get that error message. And let's actually throw an error here. So say, uh-oh, this didn't work as expected. I'm going to create an error. So I don't know if we've talked about the syntax before, but by saying throw, that means we're going to create an error here. And what error are we going to create? Well, it's a new error, and we're going to pass in as the message the error message that we extracted from this text. And so now login, if it worked, it's just going to return true. Otherwise, it's going to throw an error. And so let's actually handle that. So let's go back into the login screen. We're going to need to import this login function from the API file that we created. And now what are we going to do? Well, in this login function here, we're going to try to log in using the password and username from state. And what are we going to do with it? Well, first let's do await. So remember, if it works, it's going to return true. And what happens if it doesn't work? It's going to actually throw an error. So let's if you think back to lecture, how do we handle errors in async functions? We do this try and catch. So now we're attempting to do this. So try to do this line. So try to log in with this .state.username, this .state.password. If it works, woohoo. But what happens if it doesn't work? It's going to throw an error. But if it's throwing an error, we don't want to crash our entire app with that red screen. We actually want to just catch that error and do something with it. Because if you remember that error message, we want to eventually show back to the user. And so we're going to do that here. We're going to catch that error, and we're going to handle it. What are we going to do with it? Well, we're going to take that message, so I happen to know, because I read the documentation on error, that the error message is stored as a key called .message. So I can grab that. And then what do we want to do? Well, we want to set the state so that the error that we show to the user is that error message. But what happened? So now we've handled the case where it doesn't work. What do we do if it works? Well, we wanted to do this .props.navigation .navigate to the other screen, whose name I deleted. But if I remember correctly, it was main. So let's go with that and hope. So if it worked, if this worked and didn't throw an error, we can go ahead and navigate to main or log in. If it didn't work, we're going to catch whatever error this throws, grab the message out of the error, and set the state. So let's go ahead and save and run this. Press to log in, missing username or password. It went ahead and worked. So if you remember, username and password right now are empty strings. And so when we send this over, it says, oh, username and password are both false, so it's a bad request. It's going to return that 400, which is going to trigger an error in that login that we wrote in API. That error is going to get caught here when we say catch error. It's going to extract the error message out and then set the state. And then where does that eventually show? Well, it shows in this text block here. And so it's a slightly different logical path as we had before, but it does the same thing. And now it's super nice because in this login screen, does anything here rely on our API being at that localhost address? Not really, right? The login screen doesn't care where we're sending our login request to. It only cares that we're sending a request to log in. And so we've gone ahead and abstracted all of that out and exposed via an API from our file called API that has a login function, that login function. And so it can go ahead and invoke this login function with this username and password. And that login function will return if it's true, and it will throw an error if it didn't work. And so we've gone ahead and abstracted out all of that, the internals of how we're communicating with our external API, and just expose this login function to this login screen. And so the login screen doesn't really care about how we talk to the API. It really only cares about this function called login. And so this is a much cleaner way of keeping only what the component cares about within the component. Any questions on that? Great. For people online, if they have any questions, feel free to send them in Slack. But otherwise, I will see you next week for a guest lecture with the founder of Expo. And so we've been using Expo all class for demos and for running our projects. And we're lucky enough that next week we have the person who founded Expo coming and giving a guest lecture on all of the goodies in the Expo SDK. So we can play around with all of those Expo components next week with Charlie. Thank you.